In 1b, it says, now if a times 10 to the negative fifth and b times 10 to the fifth are written in scientific notation, is it true that a times 10 to the negative fifth is less than b times 10 to the positive fifth? And explain. So a and b, being in scientific notation, says that it has to be between 1 and 10 so that it can be in scientific notation. That means that even with a being as close to 10 as possible, 10 to the negative fifth is still going to be significantly smaller than 10 to the positive fifth. We can say the maximum value of a times 10 to the negative fifth will still be smaller than the minimum value of b times 10 to the positive fifth. They're not going to be a power of 10 away from each other because they can only be between 1 and 10. So they're not going to be that significant in size. The exponents plays a much more important role in this than the value of a and b because they are stuck between 1 and 10. Number 2, the mass of a neutron is approximately 1.674927 times 10 to the negative 27th kilograms. Recall that the mass of a proton is 1.672622 times 10 to the negative 27th kilograms. Which is heavier? So, since they both have the same exponents on the 10, we no longer need to consider that in terms of its size. Next, we're going to look at the values we see here. Is 1.67 more, or 674 more, or is 1.672 more? Which one is heavier? We want the one that weighs more. The neutron or the proton? The neutron, oh, I spelled it wrong there, is heavier because they both are 10 to the negative 27th, but 1.674927 is greater than 1.672622. So the neutron is heavier than the proton. The average lifetime of the Z boson is approximately 3 times 10 to the negative 25th seconds, and the average lifetime of the neutral row Mason is approximately 4.5 times 10 to the negative 24th seconds. Without using the theorem from today's lesson, explain why the neutral row Mason has a longer average lifetime. So that means we can't just describe it based on the exponents. So to be able to compare these, we need to change them to have the same exponents. We have neutral row Mason is 4.5 times 10 to the negative 24th. And the Z boson is 3 times 10 to the negative 25th. But if we want to rewrite it as 10 to the negative 24th for comparison's sake, it would be 0.3. I have to move that decimal one spot. So with the exponents being the same, which one has a longer lifetime? Well, 4.5 is more than 0.3. Therefore, the neutral row Mason has a longer lifetime. B, approximately how much longer is the average, or is the lifetime of the neutral row mason than the Z boson? So we're going to take 4.5 times 10 to the negative 24th, and we're going to subtract 0.3 times 10 to the negative 24th. Remember, when subtracting, the exponent stays, and all we have to do is add or subtract. This time we're subtracting the numbers out front. 4.5 minus 0.3 is 4.2. And this is in seconds. If you were to look at my addition, it uses how many times longer, but because yours is worded as how much longer, we are subtracting. Remember, if it says how many times longer, we would divide. Don't forget to put your name on your paper.